Hi everyone, thank you for coming. Thank you for the Skeptic Society for hosting. I hope that everyone finds today both valuable and enjoyable. So today I wanted to present kind of an integrated approach to belief and evidence. They're fundamental concepts, we use them day in, day out, and they might seem a little mundane, but perhaps because they are so fundamental, we want to examine them, make sure we've got a good kind of well thought out way of approaching them. The approach I'm presenting, it's kind of assembled from a range of different philosophical positions. I think each of those positions is strong on its own, but especially when you combine them together, the package is very cohesive. The mainstay of the approach is Bayesian epistemology, which has been getting a lot of attention recently. Epistemology being the philosophical study of knowledge. What is knowledge? How can you obtain it? And let's jump right in. There are cookies hiding behind the doctor. Do you want to pass those around? Prescribe. So all these terms here, I think that it is my opinion that I believe that, and I know that, we apply them to propositions, to statements about the world. They express that we take something to be true to some extent, and they're each slightly different. I believe that something isn't quite the same as I know that something. And one of the things that we're going to get up today is that we'll be able to more clearly see, using this approach, where each of them falls, how they get used. First off, I want to be clear about what I don't mean by belief. Usually, people use the word belief when they're taking something to be true, even though it's difficult or impossible to prove. So you'll hear the word belief used a lot in religious and ethical contexts. So let's say someone will say something like, I believe in ghosts, since evidence is difficult or impossible to produce. Whereas if you know it, you'll just say, I know there are elephants in Africa. That's not what I mean by belief. I want to use belief in a more inclusive, broad, technical way. Here today, belief includes any proposition, description, hypothesis, or theory about the world, or how it works, which you might take as true or as false. Simple example, Shakespeare authored Hamlet. That's a belief I might hold. Or I might think it was plagiarized, so Shakespeare authored Hamlet is then a belief which I reject. Or to give an example of a belief about how the world works, I might say there is an attractive force between any two masses which pulls them together. That, again, is a belief. Well supported, but it's still a belief. A belief that I might reject might be that the position of the stars at the time of my birth affects my personality. Personally, I reject that one. So I think the evidence supports it. Now, I've just been speaking right now as though you believe something and you don't. You think it's true or you think it's false. Kind of very absolute. But that isn't quite right. Not everything that you believe do you believe to the same extent and with the same certainty. Nice, simple example. I believe two things right now, among others. I believe that I have 5 fingers, and I believe that Angela Merkel is the current Chancellor of Germany. I think these are both true. And yet I am far, far more certain about the former than the latter. While I could be mistaken about having 5 fingers, there are scenarios I could imagine whereby I have really terrible vision, or don't know how to count, or I've suffered a stroke, and who knows what, really humans have 6 fingers and my brain's just scrambled that. That's pretty outlandish. And yet there are some really simple, easy ways in which I might have stuffed up in believing that Angela Merkel is the current Chancellor of Germany. Like, I might have just misread it in the first place, I might have misremembered it, or she was until very recently and then something happened. Let's say she was abducted by aliens and then the Bundestag replaced her and I hadn't read about it yet. So, far more certain about one than the other. So given that we're not equally certain about all beliefs, we can think of them as coming on kind of a sliding scale of certainty. sliding anywhere between you're absolutely certain that it's true, all the way down to you're absolutely certain that it's false. And since it's a slider, we can almost even go a step further and represent this numerically, quantitatively. So if I think that something is 3 more times likely to be true than false, I think there's a 3/4 chance it's true, I can say that means I think it's 75% likely to be true and 25% likely to be false. So I can just simply say I have a kind of belief strength or certainty, however you want to term it, that this belief is true. And up on the slide, there are just some examples of just kind of where you might be on the slider. And I just want to point out that even though we're kind of using numbers here to kind of measure belief certainty, that doesn't mean you should go and try and attach a number to your actual belief. You shouldn't try and look in your head and say, oh, I'm 93% sure about that, because your head doesn't give you numbers like that. Theoretically, there's very good reasons for doing this, mathematically and scientifically, but when we're actually plugging in precise numbers like that, that's far more for learning how they work, maybe in practical calculations when you've got very clear numbers to start off with, not for just saying, I think it's going to rain tomorrow with 72% certainty. But it is very, very useful. And the maths behind this, in the Bayesian epistemology, they give you all kinds of interesting properties of beliefs. One of them, I think, which is most fundamental, is that you can never have 100% or 0%. You can never be absolutely certain about something. And a quick, easy way to kind of see why that should be true is if you're 100% certain about something, then you can never change your mind about it. Suppose I am 100% certain, beyond any doubt, there is absolutely no way that the moon is made of green cheese. If that is the case, and if that is the strength of my belief, then even if an army of astronauts carrying plates of green cheese comes back to Earth saying, look, turns out the moon's made of green cheese, how about that? You want some? I will not be able to change my mind, because I am absolutely certain beyond any doubt, which means no matter how improbable evidence I get, it must be that the evidence is wrong. So you always want to leave some possibility that, someone will give you the red pill and it turns out, you're in the Matrix or something crazy impossible, just so you can change your mind. So very close to 100%, never exactly there. And the same goes for 0%, absolute certainty that something's wrong, because that's just the flip of absolutely certain that something's true. Now, this is adding in another kind of philosophical premise to the Bayesian epistemology idea, and that's that any proper or well-formed belief doesn't just describe the world. It describes the world in such a way that you can make a prediction out of it. It says, this is what you expect and this is what you don't expect. This might seem a little strict of a requirement, but I think that in practice we all keep to it. So a simple example here, let's say I've observed an anvil falling. And I ask, why did the anvil fall? And if I ask anyone, walking around these days, most people are likely to tell me it's because gravity pulled it towards the ground. Gravity causes two objects to come together. And that is a helpful, useful, informative explanation, because it tells me what will happen next time. If I see another anvil and another earth, and I see them, suspended apart, I will expect they will fall together. It makes a prediction. It tells me what to expect and what not to expect. I don't expect it to float upwards. If it floats upwards, I will be very surprised. Contrast this with if someone had just told me, well, the anvil fell downward because it wanted to. That's where it wanted to go. I have no idea what to expect next time. Maybe the anvil will go upwards. Maybe it'll go sideways. Who knows where the anvil will want to go? It's not an explanation which constrains. And I think that really is a fatal flaw in a belief. And that might seem simple there, and we're not likely to fall into a trap like that, but these kind of improper beliefs, as I'm going to term them, actually do creep in a bunch. One example is actually with legitimate theories, just when we're studying them, where we might not study them in depth and we don't have a full enough grasp of them to actually know what they allow and what they don't. So there's a story of a bunch of kids, and they'd been studying about thermodynamics for a while, about heat. How does heat work? How does it move? And one day they come into the classroom and the teacher says to them, "Hey, look over here. Look at this metal plate I've got up against the heater. The outer side, it's hotter than the closer side. That's a bit weird, isn't it? Why do you think that is?" And the kids start umming and ahhing and going, conduction? Nope. Convection, air currents? Nope. And they keep guessing with all the different terms that they've been learning all semester. Till eventually the teacher says, "Look guys, the plate was up against the heater, as it with the closer side hotter, the further side away cooler, as it should be, right until you guys walked in, and then I flipped it around." Thermodynamics does not allow for the closer side of a metal plate which has been sitting against the heater for any length of time to be cooler than the further away side. This just violates kind of all the rules. But the kids didn't have a good grasp of what thermodynamics, as understood today, allows and doesn't allow. They just had a few terms in their head. So no matter what they'd been shown, they'd just try and see, well, how does that fit with what I know? And they'll just start applying terms left and right. And the teacher pretty much could have shown them anything, any impossible thing, and they would have explained how it worked, with their kind of amorphous, twisting views. Now that's kids who didn't properly understand something, which was an entirely proper, well-formed belief and explanation. But actual scientists have made this mistake. You go back to the 1700s, the reigning theory of fire was called phlogiston theory. And pretty much whatever you asked about fire, it was explained by phlogiston. What's the orangey, bright, burny stuff? That's phlogiston. Why does it turn into ash? That's phlogiston. And there were all these kind of clever explanations as to why this kind of phlogiston in the substance burning acted the way it did. But it never made any advanced prediction. It never told you, this is what you should expect, this is what you shouldn't. Pretty much, there was no way to falsify it. So one example might be that, we're going to light a fire and then put a glass container over the top of it. Phlogiston theory didn't tell you what was going to happen next. But once you've done the experiment and you put the container on and you see, oh look, it's gone out, then phlogiston theory can tell you, why did it go out? It went out because all the air is now saturated with phlogiston and there's not enough room for further phlogiston to escape from the substance into the air. Great in hindsight, doesn't help in the future. And I think we always need to ask, what difference of expectation does the belief result in? What do I now expect and what now do I fail? What do I not expect? So I now want to take a quick look at truth. I think truth is quite a simple matter, and I just want to kind of restore or make a kind of quick case as to why it should be simple and not complicated. People say all kind of funny ideas about truth. Truth is a construct. Truth is relative, subjective. It's not about. It's truth is when your beliefs are all consistent. And I think these are all funny notions which kind of muddle things. And so I'll just make a simple case as for why we should just view truth is quite simple and straightforward. First off, there's a long-standing, not to be concluded anytime soon, philosophical debate about whether there's an external world or not. And that's possibly a really interesting question, possibly a legitimate question. And in philosophy class, I will have lots of fun with it. But I'm not just a philosophy student, I'm also an engineer, and I'm interested in doing practical things. And so this here is a very practical way of looking at truth. So, just before I was saying how a useful belief makes a prediction. It tells you what to expect and what not to expect. So it's helpful to have a different name for the thing which makes the prediction and the thing which determines whether the prediction was correct or not. So the thing which generates the prediction, I call that the belief. That's the thing which is in my head, my mind. And the thing which determines whether that prediction was correct or not, that's the external world. If I believe there is cake in my fridge, I predict that upon opening the door I will find cake. If I am then wrong and I find pizza, it's not something in me which made it wrong, it was the external world, or what I am labeling the external world. Maybe the external world exists only in my mind too, but it falsifies the predictions in the other part of my mind. So let's just label the one belief mind, the other external world. From there, it's a very simple step to say truth is just when what is in your mind, your belief, your expectation, your prediction, matches the actual world, what you get. If I believe that outside is a red car, outside I get a red car, that belief is true. Very simple. And so when someone comes to you and they say, look, I've got this miracle cure snake oil, it'll cure your arthritis. And I say, is that really true? And they say, well, what do you mean by true? And I mean, well, will it cure my arthritis or not? Now, on the poster I advertised that I'd address the question of subjective truth. Can there be a different truth for me and another truth for you? Some people are fond of saying this. And it would just seem, based on all experience, that we share that thing which determines whether predictions are right or not. There's one for all of us. If two scientists are doing an experiment and each has a different theory, they each predict a different result, only one of them is going to be happy. And it doesn't matter if the experimental difference of a well-formed proper belief is not something you're going to find out anytime soon. I don't really know too much about it, but I've heard that string theory is criticized because it's so incredibly difficult to test its predictions. Still, if two different scientists have two different theories about string theory, an experiment which might cost trillions of dollars and enormous amounts of energy would show the difference, only one of them will be right. And in the absence of that evidence, you don't get to say things like, there's one truth for you and one truth for me. And even supposing that there were different realities for different people, it would be another big jump to then say that you get to pick your reality based on what you want to believe. That would be really convenient and nice. Hasn't been shown to work. So, having covered belief and truth, we can now talk about evidence. Earlier I stated that beliefs vary in certainty. We can position them differently on the slider, how certain you are. But in addition to individual beliefs differing in certainty from each other, the same belief can vary, your certainty in the truth of that belief can vary over time. You learn new information, you experience new things, and suddenly you view it differently. So the question is, what does that sliding up and down the slider? Well, that's evidence. Evidence is anything, any observation, which makes you more or less certain about the truth of the belief. Beliefs make predictions, well-formed ones, and the world determines whether that prediction was right or not. And every time you have an observation of the world which says your belief was right, that prediction was correct, you become more certain that it's true. And the converse is also true. Every time you get a result which contradicts what you expected, that is evidence against it. And it's those observations of kind of expectation fulfilled, prediction falsified, that constitute evidence. But saying matches or confirms or a prediction isn't very precise, nor is saying contradicts the prediction very precise. Things aren't usually so clear-cut. So I'm going to be a bit more precise, perhaps a bit more technical. So an observation confirms a belief if it confirms that belief more strongly than alternative beliefs. And the converse, an observation is evidence against our belief if an observation which other beliefs predict more strongly than our belief. So you might have two theories, and they both say this result could happen. We think this is on the allowed list of outcomes. Like you might if one of those theories expects that result much more strongly, it's evidence in favor of that. Here's an example to demonstrate that. It's a bit wordy. Let's say I've dug up this cool coin in my backyard. And I have two theories about how this coin is weighted. Theory one is just that it's a fair coin. Heads and tail are equally likely. Theory two is that it's a biased coin, that heads is 9 times more likely than tails. So both these coins allow you to get heads, and they both allow you to get tails. However, one of them, theory two, tells me to expect heads far more strongly than I do tails. So if I get a heads, that is evidence that this coin is biased. Even a single heads, you expect heads more based on theory 2 than on theory 1. And the converse is also true. A tails, even though both coins allow tails, since it's predicted far more strongly by theory 1, allowing out in 1 out of 2 tosses as opposed to 1 out of 10 tosses, makes its coin seem fair. The evidence isn't conclusive. I'm hardly going to say absolutely, but it is enough to adjust your certainty about, say, the relative certainty of these two theories. Having stated that, we can kind of make a categorization, a slight distinction between strong and weak evidence. Strong evidence is the evidence we normally think of, the evidence people normally produce as an example, and strong evidence is any strong evidence is any observation which is predicted really strongly by one belief and not at all by the alternatives. So, let's say we have the belief, the proposition, it is raining outside. And then we go and look outside, and by golly, it is raining. We see raindrops, we feel raindrops, we hear raindrops, we taste them, we smell them, etc., etc. That is really good evidence that it's raining. Why is it such strong that it's raining? Because you don't expect any of that at all if it's not raining. The belief that it is raining outside predicts that very strongly. The belief that it is not raining does not predict that at all, these observations of raindrops and so on, barring hallucinations and other crazy, weird examples. And that's the kind of evidence most people talk about. They talk about, do we have evidence that, he's guilty? Well, he came out and he's, had blood on his hands and he was holding a knife. Really strong evidence. You don't expect to see that if he's not guilty. But there's also weak evidence. And this, I think, people don't notice as much because it's much more subtle. And that's when an observation is predicted slightly more by one theory than the alternative. They both allow it, but one just says it's slightly more likely. So to use another kind of rain example, we have two different beliefs. One, it's going to rain today. One, it's not going to rain today. And we walk outside and we observe something. We have this observation. There are white, fluffy clouds. That is not strong evidence one way or the other. But it is weak evidence. Because on which day do you think it's more likely there'll be white, fluffy clouds? A day when it's not going to rain at all? Or a day when it will rain? You'd expect fluffy clouds of any sort to occur more so on a day which rains than a day which doesn't. And so although not conclusive, it's enough to kind of just boost your certainty a little bit along the slider that it is going to rain today. The more clouds and the darker they get, the more likely you are to take an umbrella. And an additional cool and I guess really important thing about weak evidence is that it adds up. Before with the coin example, I said no, single heads makes you particularly sure that the coin is biased. But if you keep tossing it, and you do 100 tosses, and 90 of them are heads, you're pretty darn certain that this coin is biased now. Each individual heads, which either coin would have allowed, together, keep pushing you up, slowly, 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 up the evidence slider. Each small, incremental, weak piece of evidence taken together, now becomes strong evidence. And people often realize that. You'll see people realize that small bits of evidence add up, such as, intuitively, 100 tosses, 90 of them heads. Most people easily say that's evidence that it's biased. But you have to notice that when you get given each coin cost one at a time to see what that weak evidence is doing and how it's adjusting. Lastly, just to deal with the word used commonly enough, and that's the word proof. Just quick disclaimer, I don't mean kind of deductive proof used in kind of maths or logic. That's a different beast and would need to be analysed differently. But proof about kind of external facts or beliefs about the world, that kind of proof. When people say that, they're normally thinking of strong evidence. Something which conclusively says, it is raining outside. Look, it's raindrops. And normally when people think that they've got this strong proof, they become 100% certain about something. So, as I stated before, and I haven't been able to argue for this as much as I'd like to, but we do not want to allow 100% certainty, because there's always room for doubt. Always a skeptical scenario, and even not even a crazy one, just really improbable but still very real world could happen scenarios in which we are wrong about something. So to say that something is 100% absolutely beyond any conceivable doubt proven is not something we should allow. You never have proven in that sense of the word. If that's what you mean by proven, you can't have it. Nothing proves something that strongly. You would need an infinite amount of evidence to prove something to 100%, and that actually works out in the numerical representation. However, if by proven you just want to say that something is really, really sure, we're pushing it up as far as we can on the slider to get as close to 100 as we can, I'm happy to call that proven. And I think there are a lot of things which are proven in that way. They're extremely certain, like Maxwell's equations describing electromagnetism. Extremely high evidence, but they still could be wrong. And the philosophers will give us all the scenarios in which that could be the case. Such as, Descartes' demon, brain in a vat, and just plain old I'm dreaming. Maybe we're all dreaming about electromagnetism. With all that under our belt, we can actually now come back to the propositional attitudes we started off with. It is my opinion that, I think that, I believe that, I know that. We can now see where do they fit and where do they get used. So, belief, colloquially, has two usages. I kind of mentioned the first one, where someone just takes something to be true, even though it's difficult or impossible to get evidence for it, such as religious or ethical contexts, where it seems the rules would be a bit different for kind of belief and evidence. But also you get belief used just plain where people are deciding to take something as true, despite there being evidence they haven't got it yet. And that's often, you'll use, say, political opinions or things which are hard to measure, like empirical facts, say the economy or effects which policies would have. You can experiment and test and figure out which one's true. But it's hard to do so, it's massive scale, and it's unlikely to happen. People just say, oh, well, you can't get that evidence easily, so I just get to believe what I want and decide that that's, 95% certain is the case. If you were to completely replace the political system with the one I'm proposing, it would work great. And that's kind of also when people use the term, it is my opinion that. Let's say there's, in a hot political topic debate, everyone's discussing, should we build quantum reactors in Australia or not? There actually happens to be lots of scientific data and evidence and experiments on quantum reactors, but people are busy and they don't have physics degrees, so they don't really care. They just want to say, it is my opinion that this is/isn't a good idea. And so that's kind of belief, and that is my opinion that. I think that you could probably say that people use this when they're saying something is true, but they're not completely confident in it. You might say, I think that she went that way, and that kind of captures, I think she went that way, but I'm not really sure. Like, don't hold me to it. And lastly, I know that. Knowledge, I would say we tend to use that, and the word arose in the context of when we're very sure. We've got strong proof, so we've got strong evidence, maybe proof, which has pushed us way up on the slider, and now we feel very certain. And we have a special word for that, as clever humans we come up with in our language, called knowledge. The problem is sometimes we know things and then we turn out to be wrong, and this is like a nightmare for philosophers who want to take things as kind of binary. You know something or you don't, you're absolutely certain or you're not. And once we allow that we've kind of got this sliding scale, and knowledge is just anything past a certain, almost arbitrary point, we want to call knowledge for convenience. I don't want to go around and say, doctor says, do you know what you had for dinner last night? Or he says, what did you have for dinner for last night? And I say, I am 98% sure that I had string beans. I just want to say, I know that I had string beans. Simple, easy word for it. And once we realize that, we can stop trying to figure out what are the necessary and sufficient conditions for truth, and for knowledge, and how do you handle kind of skeptical scenarios where you might be wrong. We say you always might be wrong. This is just the word we use for things where you're really certain. So I'd say that this kind of way of looking at things, it's not just interesting or helpful in a few kind of philosophical problems. It's actually very helpful and almost critical in actual day-to-day life in responding to evidence and changing our views. So I'd like to just bring an example of how you get two different outcomes, depending if you were following the approach presented here of belief and evidence and kind of a default, the way most people react. So there's another political debate happening. It's happening on planet ER. On the Earth, everyone's up in arms about the question of whether a giant mutant star goat is going to eat the planet or not. And John is a staunch member of the Star Goats Friendly Party. He is absolutely certain that this giant friendly critter is going to do nobody no harm. And he's got, he's read all the literature, he's got, all the pamphlets and books even by the famous scientists and star zoologists and so on. And he knows that, could not be. He's got argument A, B, and C. And so John goes out in the world and he encounters Anne. And Anne has an argument that, we should be worried. We think that this star goat is dangerous. And he debates, Anne and John debate a bit, and John's got his 3 argument, and Anne's only got 1. And John's absolutely sure that he's right. And so he just dismisses Anne. He says, sorry Anne, my case is much better than you. Clearly, the star goat is friendly. And the next day, same thing happens. John goes out and about, and he encounters Bob with an opposing view. And Bob has an argument, a piece of evidence, suggesting, again, the star goat is not so friendly. But John's got 3 arguments, and 3 beats 1. And then up, John encounters Carol. And Carol's actually got 2 pieces of really well thought out, well sourced evidence. But still, 2 is not 3. John is better. John can completely disregard Carol and everything she has to say because she's wrong and he's right. Look at my whole stack of proof. So at the end of the day, John is just as sure as he ever was that he is right, that his position is right, that his political party is right, because he had more evidence. And every time he met someone else, no one else could, outdo his evidence. The thing is, by the end of all this, John had actually encountered 4 pieces of evidence against his view. And he had only 3. The evidence against, taken up together, overwhelmed his. But he didn't look at it all together. He kind of, as each one came up, he dismissed it, completely ignored it, didn't alter his certainty on the slider of his belief at all. Had he taken each piece, each argument, each evidence as evidence as an observation which counts against his belief, slightly adjusting down his certainty, maybe also including for the fact that these people are biased and wrong and crazy, but that still looks valid or could be valid, so I should be a little less certain of my view, he would have ended up changing his mind a bit. He wouldn't have come out, having encountered all this evidence against his view, with exactly the same level of certainty. And I've done this. I've been in a kind of political discussion with someone who held a diametrically opposed view to me, and they were presenting me some evidence, and I just wouldn't hear it. And I left in a huff. I was annoyed. How can you doubt this? Your evidence is completely wrong. And I felt exactly sure as I was before, not even granting the possibility that their evidence, even a scientific paper, was valid. And I guess that's kind of what I would advocate as the outcome of treating views these ways. You respond to evidence. It might be a tiny bit. You might adjust only 1% down in your certainty when you encounter evidence against what you think is right. But it has the effect that if that evidence keeps coming on and stacking up, you'll change your mind, probably in line with the truth. Just go where the kind of winds of evidence blow. So a quick review before we look at the final topic of cognitive biases. Cognitive biases being systematic thinking errors. So we'll just kind of wrap up what we've just covered in a nice little diagram here. You have your kind of original belief coming in, where you're at on the slider. You encounter a new observation, new evidence. You combine them, you process them, and you come out with an adjusted belief. Or an adjusted belief certainty, either more or less certain. That processing box, it hides quite a lot. You get the kind of the workings of that Bayes theorem's down there in a couple of different forms, and it gets messy. But your brain actually does handle that fairly efficiently if you let it do it. Just to say, I've got evidence, I should feel a bit less certain, a bit more certain, and so on. And that's what I'd say calls the ideal process for kind of belief formation and updating. You might ask kind of where do you start off begin with from a clean slate before you've had any evidence whatsoever, before you've got any beliefs? So you always come kind of preloaded with beliefs. You're pretty much born with beliefs. And certainly by the time you question you're asking, you've got a bunch of beliefs or certainty, and you can start kind of updating them in this way. But yeah, I would say that the human brain comes pre-programmed with kind of like a set of default beliefs you'll launch off. So cognitive science is a scientific study of how the mind works, of cognition, of thinking. And out of all the sciences, this is probably the one which should really be of interest to everyone. Everyone's got a mind. Everyone is, thinking day in, day out, making decisions. And you should want to know how that works. If you're relying on a tool that much, you want to say, what are its limitations? How does it work? Maybe I'm not using it quite right. And that's why I'd say that everyone really should get into cognitive science. And one of the most relevant fields in cognitive science was founded by Amos Tversky and Daniel Kahneman. That's the field of heuristics and biases. Kahneman actually received the Nobel Prize for economics, the first non-economist to do so, for his work. And that's his book there on the left, which I highly recommend. So what are heuristics and biases? A heuristic is kind of like a shortcut, rule of thumb, quick way of doing things. It's not the perfect result, but it's usually close enough or good enough. Let's say someone asked me to quickly calculate what's 123 times 84. That would take me maybe 10 seconds to do fully proper. But if I just say, oh look, they're both close to 100. 123 is close to 100. 84 is close to 100. I'll just do 100 times 100. 10,000. Do it in a second. And that's really quite close to the exact answer. The exact answer is 10,332. So only off by 332 on 10,000. Quite close. Took, maybe a 20th, 30th of the time. And the brain uses lots of these kind of heuristics because they're fast and they're cheap and they work quite well most of the time. The problem is we've got so many of them and we don't know what they are and we don't know when they're operating, that often we're taking them into situations where those heuristics weren't designed for. Such as, you don't want to be using a heuristic like 100 times 100 instead of 123 times 84 when you're building an aeroplane or a rocket ship and not know it. And yeah, that kind of is what we're doing day in, day out, using our minds, not knowing how they work, not knowing the heuristics. And heuristics often give rise to biases. And a bias is a systematic thinking error, which can arise because, say, you're using a heuristic when you shouldn't be. And why are they systematic? Well, they're not just like errors, because you keep missing in the same way, you keep making the same mistake. It's predictable. Hence the name of Dan Ariely's best-selling book, Predictably Irrational. Quick illustration, suppose you have a target, missing would just be like here, 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 here. Systematically missing, all your shots are off to the left. And that's what we mean by kind of a bias in this context. So I'll look at a few of them just to kind of demonstrate where these biases creep in and why I might want to look into them. This is kind of just more a taster. I encourage anyone who's interested to take a further look into it, perhaps come to future events we might run. Let's have a look. So, motivational biases aren't really news. And we often see, other people committing them all the time. Motivational biases pretty much include the confirmation bias, which is everyone has heard of, whereby pretty much you have a belief, you want to you want to take as true. Either you think it's true and you only want to continue to believe it's true, or you want to assemble evidence to prove that it's true, and that is going to completely distort your thinking process. There are all kinds of clever ways your mind is going to find ways to produce evidence for the view you want to believe is true. It almost seems really that the human mind is built to do this, and we're kind of fighting against ourselves if we actually want to get to the truth and not just a truth which we want to be true. Here are a couple of examples of ways which you might be motivationally biased, say in your collection of evidence. Let's say I'm doing research on a given question. I do a Google search, plenty of results, about, 20 really high quality results, and I read the first 3 and they tell me exactly what I want to hear. Perfect. Just as I thought, just as I suspected. Close the laptop. It would take very little effort for me to read another 3. I can see that they're evidence against. And I don't really want to read that. They're right there. They're accredited sources, but I'm going to ignore them because I've got exactly the evidence I want to hear. That is motivated stopping, where you just close the laptop, say I'm done. The converse, the flip side, is where you did the Google search, you got 100 results, and you keep reading them, and none of them are saying what you want to hear. This is not what I want to believe. I want to find someone who agrees with me. And you're going to further and further extents to find evidence which supports the view you want to take as true. So soon you're kind of on the top shelf of the back bookshelf on the library on the other side of town, trying to hunt down evidence which supports the view you want to take as true. Just a word of warning, it's really easy to see biases in other people. We're almost blind to them in ourselves. There's actually a bias called for that bias blind spot. There's a really interesting book I want to read, can't say I have read it, called Why Everyone Else is a Hypocrite, which looks at kind of evolutionary psychology reasons for why the human mind does this, using knowledge of biases just as a way to discount others than examine ourselves. So I guess what I would really encourage you to say, if you're going to think about bias, always ask, when am I doing this? Not when can I find examples of other people doing it. Probably the fatal flaw of the human mind, in my opinion, is that your mind is a clever arguer. We love to start with the conclusion and then do our reasoning and justify it. Should I eat this piece of cake? Subtext, yes. Let me justify it now so I don't feel guilty. The problem with starting with your conclusion first is that it doesn't matter how clever your reasoning is, the conclusion will still be wrong. as if it was wrong to begin with. The truth of the conclusion has nothing to do with your reasoning once it's already taken as the conclusion. I take for example, I'm at a really vicious debating tournament, and the topic I'm told I have to argue, the side I have to argue for is that the sky is green. This is the conclusion I start off with. I write it at the bottom of the page. Now, it doesn't matter if I am the best debater in the world, no matter how clever I am, nothing I write above that conclusion is going to make it true. It was wrong before I started. And this is kind of blatant, this is clear, but often our mind likes to hand us conclusions before we do our conscious reasoning, and the conscious reasoning is just the justification. There was one time where I was invited to a party, and I was saying all the reasons why I should go. Why? Because I had split second decided that I was going to go, and now I just wanted to convince myself that it was the right decision. But my decision to go had nothing to do with the reasoning, and that reasoning didn't determine its truth. The truth, whether it was a good idea or not to go, was determined by whatever subconscious process or thing I'm not willing to admit myself generated that conclusion, that split-second decision. And what I do these days is I try to catch them. I try to say, wait, am I doing reasoning now with the conclusion in hand, just trying to justify it, or am I actually trying to make the best decision I can, starting with a blank sheet of paper at the top, doing the reasoning, pros and cons, costs and benefits, and so on. I think we're getting towards the end of the time. It will take me about another 5 minutes to finish. I don't know if people want me to keep going. Got 5 minutes? Okay, sure. So now a couple of example of biases which mightn't be quite as obvious, but are every bit as much as real. I said before that a heuristic isn't quite a bias, that it's not necessarily a bad thing if it does a good job, a quick job, saves you time and effort. But here's an example of a heuristic which often goes astray and causes us to make bad decisions. And that's the affect heuristic. Affect is the fancy psychological word for emotion. So the affect heuristic is where people use how they feel about something, kind of on a gut level, to judge it overall. I have a good feeling about this, it must be a good thing I have a bad feeling. And the problem with that is, the reason they have a good or bad feeling about something is normally just, for one aspect of it, which doesn't apply to the overall thing. You might have some question. There are 5 different aspects of it. One of those aspects is positive. You now feel positive about all of them, and you incorrectly assume that the thing is positive. So some of the study into this was with risks and benefits. People assume that if something is low risk, then it's got to have lots of benefits. This is not so. Sitting at home, looking at a blank wall, is really low risk. Very few benefits. And they did this study, they looked into nuclear power, gas power, and food preservatives. And in each instance, if you told people that they were low risk, these people would start making assumptions like, oh, well, if it's low risk, then it's more likely to be good for the environment and generate cheap electricity and so on, or be good for your health, in all these ways. Entirely unjustified, unlinked assumptions. And a specific manner in which the affect heuristic plagues us is with the halo effect. And this is where you, again, looking at just one aspect, having a good feeling about it and judging overall. And you can do this with people, as it says on the slide, but it also applies to any other ideas or ideologies or any of these things. You get a good feeling about them and you start thinking they're great everywhere. Let's have an idea of a halo effect, whereby good belief about something in one specific area you think it's amazing in general. Let's suppose there's a new medication out. It's a medication to lower cholesterol, and it is a miracle drug. It works wonders. Absolutely brilliant. Soon, all these people with their cholesterol is lower, they start saying things like, and it also lowered my blood pressure, and I've also lost weight, believing that this drug can do anything, when there's no evidence to think that. They've just jumped, it was good for this, therefore it's got to be good for that too. A lot of the experiments into this effect were looking into attractiveness, fairly easy to test, to see how perception of people's attractiveness affects their perception of them in other ways. So you just get, say, a bunch of photographs of random people. You have one group of participants rate the attractiveness, and then another group of participants kind of guess how friendly they are, how smart and clever and kind and honest and hardworking. And there is an incredible correlation between the ratings of attractiveness by one group of people and the rating of how good and kind and clever and smart and nice they are by the other people. And this actually has real-world kind of effects. We have a study looking into the Canadian federal election showing that attractive candidates, is assessed by one group of people, kind of randomly picked, got 2.5 times the votes of the unattractive candidates. Which is a little disturbing because you don't want to, select your public officials based on appearance. I mean, it's great if the politician on TV is good to look at, but we've got people running the country, not a beauty pageant. And the additional thing is that when they surveyed, voters, 73% very strongly, forcefully denied the possibility that appearance had any bearing on who they voted for. Just 13% said that, it was maybe possible that their voting decision was influenced by appearance. And this can affect individuals too. I mean, let's say you're an employer and you're hiring someone for a position, and you've got two candidates, a better-looking one and a less good-looking one. And once you hire them, they're working out in the field or on, a different floor of a different building. You're not even going to see them. So what you really care about is how hardworking they are, how effective, how well they're going to do the job. Not how pleasant they are for you to look at them right now for this 5 minutes. So you don't want to get sucked in and assume, the better looking one must be the harder working one too, if what you really want is the harder working one. So these were all just a taster of different biases which can creep in. I hope that learning about these actually scared you as much as it learned me. There's actually a really long Wikipedia article of the different biases, and it just worries me to kind of think, I'm making all these mistakes. I don't even know what I'm doing wrong. I hope everyone enjoyed today's talk. That's pretty much it. In case anyone's wondering, I'm Ruben. I study engineering and philosophy and psychology, and I'm a member of a group called Less Wrong, and we attempt to promote thinking and decision-making skills with the hope of improving the world. And kind of this talk was very much the basics, the 101 of our approach. Thank you again to James for hosting.
Yes, everyone join me thanking Ruben for talk today.